Alright, time for another DraftPhysics.com video presentation. So we're going to go back to an oldie but goodie, an AB Science Explanations for Mechanical Gravity video. Made a couple of years ago, and I had some text conversation with AB Science, attempted to get him to interact on these subjects. The giveaway moment was when he pretended he didn't understand the concept of thrust in space, because I made the question was posed, what's going to move the spaceship, the kinetic energy or the momentum? And he just wouldn't answer the question plainly, and pretended somehow it was inappropriate to ask. Thrust wasn't a real concept. But anyway, so it just, it's the same thing as the physicist Michael thing. It's just evasion and insults. Degrade the conversation enough where you can make an excuse to bail, because you really can't make any arguments. And it was the same kind of thing. I kept asking AB Science, well, how much do I have to just pay you to answer my questions? Just answer my frickin' questions in a video. And he just wouldn't give a price. And, well, he did. I think he said $1 million. He was making a joke. Anyway, it's just, is there any point? Then I just noticed that on my website, the YouTube embedded videos don't work. So I guess YouTube is, that's the Ephelism website. Where the hell did it go? DraftScience. There it is. So that's some AB Science text crap I was just looking at. And so I'm going to do some work on this, of course, because I have posted a lot of stuff here just to see if I could get Google and Bing and, the different real search engines to actually index some of the content on my website, and they really won't do it. But yes, this is like, what is this? So you click on the video and it doesn't play. So all the embedded videos stopped working. So, I guess that's some sort of YouTube punishment, of some kind. But whatever. This shouldn't be behavior that's acceptable on the internet. This silence, the internet. Silence the parts of the internet you don't like. And that's all it is. And this is Google, the search engine, that doesn't index the internet. Clearly, it doesn't index. It doesn't spider. Okay, it doesn't include in the internet the comment sections on its own platform, YouTube. In the old days, this would have been seen as a huge fail for a search engine. A search engine that doesn't actually index pages, nobody would have used that search engine, But that's back when there was a competitive environment and you had to earn a view. And now it's this monopoly thing where you don't have to earn it anymore. You just go to the platform monopoly, and that's who you'll have to deal with. And you really aren't going to have any viable choices. And that's a tragic failure of the public. The internet that's supposed to be owned by the public, and now it's just a corporate internet. And frankly, this is sad, pitiful. This is the environment you got to function in. Alright, so let's play this AB Science video, because it just brings up the subject, some context to somebody might care. But there really should be a rational give and take on these subjects, and there's no place to do that. Physics can't be debated. It's clear, especially any of the elemental axioms, the fundamental beliefs. You must believe in their elemental fables. And yes, as long as you believe in those, then you can argue fine minutia points, but you can't argue any of the foundational points, the wooey bits. So it used to be called AB Science. He changed the name to something, I don't know, Fool's Gold or something, I don't know, some chemical. Real life, I guess, has interrupted him from this YouTube stuff, and so he doesn't bother for the last couple of years. And so I guess he's working on something in physics.
Someone asked me to look into a topic called mechanical gravity.
Right, and the only reason why they asked you to was because I was trying to provoke you to talk about it. And again, it's so much like the physicist Michael. Talk to me indirectly, but don't talk to me directly. That kind of bullshit. Make a video degrading and insulting something I'm arguing, but don't actually reference my argument. Pretend it's some other argument.
I had a quick look into this and it sure seems to be rather interesting. In a nutshell, mechanical gravity refers to a set of ideas that were being developed in the time between Newton and Einstein. Famously, Isaac Newton derived.
It's obviously everybody was trying to figure out how the world works, so it's not some particular thing. It's just this idea that, okay, what are you going to come up with as explanation for how the damn thing happens? Why is there gravity? And these are pretty damn good guesses, considering these people didn't even know what microbes were.
His law of universal gravitation based on observations of the moons around Jupiter, to which he applied his laws of motion. Now, Newton talked about how he did not know what the mechanism for gravity is, and this is why his friend...
So, again, he did talk. In the end, he just gave up, okay? That's the truth of it, all right? I mean, he had lots of theories that he liked and, he played with for a while. But they all fell a little short, and so then he just answered the question with, I don't know. Because it was easier than explaining all the possibilities that could be a good theory, but yeah, they have a flaw. They have something that breaks the function. And look, I might as well just say it right now. Einstein cheated, is the simple truth. He created a mechanism that doesn't have to be accountable. It's a non-energy source mechanism. So we know gravity is an energetic mechanism. We know it manipulates energy. It takes your energy going out. It gives you energy going in. It's an energetic, real thing. And he just made it into something unaccountable. So he basically said, yes, it's Lesage gravity, except there's no particles, there's no things, there's no reality. There's no physical element causing it. So all of the symptoms of his mechanism, there aren't any. Because it's not a real mechanism. It's geodesic. It can't create drag. It can't create any side effects. So it's immune to side effects because it's just a magical... It just does. You might as well just say it just happens. It's so non-physical.
Framework is called Newton's law of gravitation and not Newton's theory of gravitation.
Oh, who cares about these silly distinctions? They're all speculations regarding what the truth is, and we all have to measure whether it's guilt or innocence. And the standard of proof should be a high standard, and frankly, you claim you've proven things that you really haven't proven. That you haven't met these high standards of what is a proof. So you could argue that evolution's been proven beyond a reasonable person's doubt, because the evidence is from so many directions, geology, biology, microbiology, it just gets deeper and deeper, and the deeper you go, the more it points to that truth. So yeah, there's a point where you could say it's not a theory, but we still call it a theory.
Of course, after Newton presented his conclusions, there was a scramble to find a mechanism behind the law. No one ever really came to an agreement.
So again, and the law isn't saying much. It's just saying that, okay, there's an inverse square law, and your gravity gets stronger and weaker, based on that law by a constant. So there isn't much to the law. So let's understand, it really isn't much to it except describing, yes, what goes up comes back down. It's not much more complicated than that as a law.
And The subject provides a great who's who of famous scientists throughout history being very wrong about things. So let's explore these ideas a bit further, because this gives an opportunity to shit on some of the greatest minds in history rather than just flat earthers whooped.
Well, whatever. So this was when, yes, he was just doing flat earth videos. And of course, they're not going to shit on anybody in any kind of with the same magnitude of shit. And clearly, Einstein can be shit upon. I mean, he is a duplicitous hypocrite to claim woo when it comes to these quantum effects. And yet his theory of relativity is woo all the way down. I mean, it's basically just saying, I'm going to give you an unaccountable mechanism, non-physical mechanism, just call it some sort of bent geodesic, some sort of magical convergence. That's what it is. It's just a magical convergence. Things just magically converge. There's no physical mechanism. I mean, please. It's woo all over the place. It's spooky action. There's no frickin' reasoned action. There's no explanation for why things move. It's just stated that they do.
And climate change deniers. I think the best place to start is actually before Newton, with the concept of ether vortices as proposed by René Descartes.
So Descartes was good, okay? So yes, the ether thing is always, that's a choice you make, right? I mean, whether you're going to come up with a mechanism that says you actually have to throw a domino, it's a domino system. We're seeing the thing. We're seeing cascades of things happening. We can say that, yes, there's stuff moving in the universe. And the question is it a bunch of dominoes? I mean, do you need a bunch of stuff to bang into stuff? Or can you just throw the damn domino? I mean, that's the question. And people can choose one or the other. They both end with the same result, and they have some subtleties, but it's basically just, what's the difference? I throw the domino from here to 10 feet away, or I, flick one domino and let a bunch of dominoes flip until it gets there. What's the difference?
In his book The World, which he wrote between 1629 and 1633, but not published until much later because of a fear that the church would consider it heresy, and his buddy Galileo already got into a tight spot with the church at this point.
So that doesn't make it very clear whether this was published before Newton. So that's the important distinction, because frankly, Descartes really laid all this groundwork for Newton. I mean, there was a huge connection between what you would call a Descartian and a Newtonian. Okay, the physics was very similar.
The treatise is an interesting one, as it does speculate on the idea that everything is made of small particles and heat is actually just the motion of these particles. But
Right, so he got the idea that, and he also stated that, the universe has its energy already in it. And you're just following the energy. It just has to go, it's in something all the time. Energy has a history. Every piece of motion in the universe has a history. It was somewhere yesterday, and it was somewhere a billion years ago, and it was somewhere a trillion years ago, or whatever you want to do. It's always been doing motion. So in a sense, it's basically saying the heat in the universe, the thermodynamics, has always been here. And it's just moving from place to place to place to place. Exchanging. It's what owns it.
Also speculates that everything is made of three elements: fire, air, and earth. Whatever happened to water, I don't know.
Well, obviously that crap disappeared with molecular theory or atomic theory, but whatever. They had to say it was made out of something. I mean, they couldn't just guess, oh yes, electrons, protons, and then they create atoms. That's a pretty hard guess out of nowhere.
Also described the three laws of Cartesian motion, and the first law states that each particular part of matter...
So this is pretty much Newton, I would almost argue, better written than Newton. So, yes, before Newton, these basic three laws had already been stated.
Matter always continues in the same state unless collision with others forces it to change state.
Right, so that's pretty much all you need to say, is that there's interaction. The interaction is what changes something. If there's no interaction, there's no change. Pretty straightforward. Interaction makes something happen to change things. There's no change without the interaction. Things don't just spontaneously change all by themselves. They have to be provoked to change.
The second law states that when one body pushes against another, it cannot give the second body any motion unless the first loses as much of its own motion at the same time.
So he doesn't stop and say, gee, that's completely wrong. Because that, by modern physics, that's completely wrong. All right. So, because modern physics really doesn't believe in conservation. The 5-ton train get converted into a 10-ton train, just adding weight to an object will destroy kinetic energy. It conserves the momentum but destroys the kinetic energy. And then you can do the inverse case where they claim experiments exist where you can bang an object with a certain momentum into another object and make free momentum, more movement, than you started with. Obviously, it's not an exchange then. They're saying an 8-pound bowling ball going twice as fast will somehow give pins more than that equals in momentum. It'll give it kinetic energy. Twice as much kinetic energy than there is momentum.
Finally, the third law states that when a body...
But it's really good. I mean, look, when a body pushes against another, it cannot give a second body any motion unless the first, you have to give it away. If you don't lose anything, they can't gain anything, and vice versa. So it's a give and take universe. You have to take energy, or somebody has to give it to you, but there's no other way to get it but then to secure it for something that has it. You have to take the heat from something.
Bodies moving, each of its parts individually tend to always continue moving along a straight line.
So that's almost the first law again, okay? Each part individually tends to always continue moving along in a straight line. So it's obvious that, yes, everything tends to keep going. It does what it's doing until something forces it to change what it's doing. So there must be a physical interaction with a physical thing, or it ain't changing.
Now this is cool because you can see that Descartes was exploring these conservation laws that are the foundation of Newton's laws, but Descartes was...
So again, it's just the foundation of Newton's laws. No, he's the foundation. He's the one who... Newton's laws are Descartes' laws.
Also insistent that the whole universe was filled with ether particles because a vacuum can't exist. The idea then is that if one particle...
Again, sort of irrelevant in this early context, where really all you're saying is, do you throw things through empty space or do you have to bang things through crowded space? And I suppose the one in the middle, the one I'm arguing for, is there's a bunch of flying dominoes. Okay, they're not filling all of space though. There's empty space between the flying dominoes. And each domino has momentum. It's moving the speed of light, and when it crashes into something, it will either stick to it and share its momentum, or it'll bounce and cause a reflection.
Moves, the empty space it leaves behind will instantly be filled by another particle, but of course that other particle leaves an empty space, which is then also filled by a third particle.
I guess I could speed this up a little without hurting it too much.
Reasoned that this causes ether vortices, which are responsible for the orbits of the planets. He saw this kind of like a fast-flowing river going around a bend. If you drop a feather or some leaves in a river...
So this is way before Newton, and he was trying to figure out why there's orbits, and he really didn't get the fact that the convergences of energy being consumed by the Earth, and the Earth essentially, more heat comes in than comes out. And that's the differential that it's working with. So he was trying to figure out how it could swirl the ether. So the ether wasn't automatically moving towards the Earth. It wasn't like the universe was full of little moving things, and anything you put in that field of stuff going in all directions the only things that are going to hit it are things heading right for it. So it's just going to be a convergence. The outside world is going to look like it's just pushing in on it from all directions. So anything thrown into a field of moving objects, gravity will happen. That is, the objects will move into each other because they will stop the pressure between them. The pressure between them will be blocked by their absorption of the pressure. So it's too bad he didn't think of that. But, you take what you can get.
Then these would go round a bend quite easily, but a heavier object like a boat would be deflected a bit, but most likely hit the bank on the far side of the bend, as the force of the water is not sufficient to get the boat to change direction sufficiently to go round.
Right, so this is also kind of like he didn't quite figure out that gravity's affecting the small bits that the thing would be made of, not the big bit itself. That the gravity isn't really affecting big objects. It's affecting the little stuff they're made of. That there is a small universe, a little tiny universe of little tiny things. And that's the first universe. That's the one where you have to describe how the motion works, because that's the one that does everything before something else happens in the big universe. The small universe has to do it first.
In this analogy, Descartes sees the water particles as the ether particles swirling around and the planets as the heavy objects. This of course implies that objects with more mass must have larger orbital radii, and today we know that this is somewhat problematic. Now, Huygens later developed this idea further.
So again, Huygens was another etherist, okay, so he's another guy who was going to figure out some way to make it into a wave or into some sort of flow dynamics. And again, the missing bit, the simple missing bit of the ether is if you make your ether out of independent little particles and you give them all a velocity and a direction, then you don't have any of this their stickiness. It's not an ether like some kind of water where the molecules are stuck to each other. They're like little bits of styrofoam and they go anywhere they want. Each individual one has its own existence, and the other ones have to physically contact it to change anything. And the fact is when they contact each other, it can't matter because they just exchange their condition. If one comes this way and one comes that way, they just exchange, and this one goes that way. This one goes that way, and this other one, this one goes that way, and this one goes that way. So nothing changes.
Such that it had an exact mathematical form. However, it did not follow the inverse square law, and Newton had already demonstrated at this time that the inverse square law is definitely a thing.
Well, I don't know if that actually happened. The argument about the inverse square law was maybe in the 5 years before Newton published, which is like 70-something, so I think Descartes' observation was well before the establishment of an inverse square law.
Huygens agreed that this was a failure in his model and attempted to update it, but unfortunately he ended up presupposing the universal law of gravitation, so from a mathematical and philosophical standpoint, it was useless. Another issue is that the ether vortex idea would lead...
So he was saying Huygens was on a dead end when it comes to explaining gravity. And it really doesn't matter because, yes, Newton kind of ended the conversation.
To only circular orbits, and we know that planets' orbits are not circular. Even though we now know that the mass distribution doesn't work for the orbits in the solar system, at the time they couldn't know. The right bodies hadn't been discovered yet. But back then the big killer for this idea was that you could plainly see that there were objects which opposed the direction of the ether vortex and thus violating the laws of motion. Neither Descartes' version or Huygens' version were ever regarded as viable theories.
Right, so why bring it up almost? Yes, that there was different attempts. You could go into Faraday and his theories of, how magnetism worked, and he had a bunch of gears inside of objects, and the gears were turning, and idler gears, and a whole bunch of weird gear theory. And he admitted, this is kind of a mess. It doesn't really work, but it's the best I can do. So, this is the best they could do, 400 years ago.
But next is the concept of ether streams, and Newton himself entertained the notion of ether streams and that normal matter was carried by the ether streams like in Descartes or Huygens' framework. and it was carried towards massive objects.
Right. So the difference is it's converging. So again, he's not making a clear enough distinction in this video between the idea of something having to give the ether energy and the idea that the ether already has it and it's converging into the earth. And again, the subtle distinction, I mean, don't really want to draw it, but I mean, it's a subtle distinction between, the idea of it being a sink, that is, little stuff is in the universe and somehow it sinks into a well, okay, and disappears, pops out in the end of the universe or something to continue its flowing. Or the idea that you just have energy in all directions, and the fact is it's going to create exactly the same effect. So having stuff that falls down a drain isn't going to be any different than if you have the stuff going in all directions, because for each individual object, all they're going to get hit by is things heading in a straight line right for them. So it's going to look exactly the same. The drawing will be the same if I have a bunch of energy going in all directions, or I have energy just going towards that one object because there's a well there. So you don't need the well. All you need is the external pressure. So all you need is energy, little bits of energy moving in all directions in the universe, and that'll create a pressure around every single object that'll look exactly like a convergence. It'll look exactly like pushing from the outside directly to the center of its mass. That's exactly how it'll look. Mock gravity works. And it looks exactly like Einstein's bent space. It does exactly the same thing as Einstein's bent space. Come on. That's what he should be talking about, is how these three things all would appear exactly the same. And which one sounds the most plausible? Oh, the idea that there's a bunch of photonic style energy in the universe that we're all being banged into by a bunch of little tiny discrete bits of momentum. Yeah, that sounds pretty plausible to me. A bunch of invisible, I mean, right now a bunch of cell phone calls are going right through me. It's a fact. I don't see them, I can't detect them, all this kind of crap. Well, I could detect them with a cell phone. But the point is what if they're ones that aren't at a frequency and I can't tune them in? They're still there.
Newton took quite an interest in this idea, but he ended up settling for, fuck it, I don't know. It's probably magic.
Right, that's what he settled for. So let's just understand, he entertained through his whole life. He would contemplate different models and try to make them work, and yeah, he couldn't get any of them to work well enough. But he liked Lesage gravity. It wasn't Lesage gravity, it was Fadio gravity back then, and he liked it. So I mean, it was okay, but it had these little subtle problems of, well, do the things break into pieces, these little tiny particles, or do they only give partial momentum? Do they stop moving? Lots of little problems that can be resolved by recognizing the model and saying, look, let's just make them indestructible, and then we don't have this problem.
Bernard Riemann picked this idea up again in 1853, where he assumed that the gravitational ether is an incompressible fluid and normal matter is an ether sink, where the ether...
Right, so it's an ether sink, he's calling it. So again, the model would look exactly the same if I just make all these bits go in all directions, because the only ones that are going to hit this thing are going to be ones that are sinking, looking like they're going in. So that's exactly how it'll look if you just ignore all the ones that don't hit. So if you just looked at the particles that do hit, this is exactly what they'll look like. So the two models are identical in terms of the force they create, the clear convergence.
Ether is destroyed or absorbed. This causes a flow of ether towards matter, and everything else just rides that flow.
Right, and it looks exactly like bent space. This is exactly what bent space would look like in 2 dimensions. So, except bent space doesn't have any physical reality, and therefore it doesn't have to deal with symptoms. It doesn't have to do with the side effects, the unexplainable side effects, the complications created by a real particle theory. So Einstein just cheats by saying, yeah, it does the same thing as that, except it's not physical, and therefore I don't have to account for where the energy goes.
However, this leads to a problem. If the ether is some medium like water that makes stuff move, it must have some energy so that...
So let me just point out, okay, I've watched Leonard Susskind, one of the most highly regarded Einsteinian explainers on the planet, and in his advanced lectures he actually uses water, okay, as an analogy. He actually does use it as an analogy for the anti-divergence, as he calls it, the convergence. So, irony much?
It can transfer that energy to the object to make it move. So if the ether is destroyed or absorbed, where does that energy go?
Yeah, so that's one of the complications. So Einstein doesn't have to worry about it because it's a non-physical, non-energy mechanism. It's just a poofy, wooey, free energy mechanism. Don't have to explain how it conveys the motion. The motion doesn't have to be conveyed to the object by anything physical in the universe. The thing just knows to go. That's really lame, right? I mean, the fact that I have to say even those words, gee, that's pretty, that's cheating, isn't it? So all these other scientists had to deal with real physical explanations, and they knew, I'm sure they knew they couldn't have gotten away with it, right? Newton couldn't have gotten away with just saying, hey, it's a magical thing, okay? Don't worry about it. It's non-physical. It's a bent geodesic. Does exactly the same thing, and you don't have to do any of this accounting for all the physical symptoms, the side effects. You can just cheat the argument by just saying, nah, it's just magical energy. They couldn't get away with it. That's the simple truth. And somehow, by the 1900s, science became so gullible that they would jump at anything. Just give me any kind of dopey explanation and I'll believe.
Riemann speculated a workaround by suggesting that the ether zaps off into another dimension or universe, but of course this creates more...
So again, you don't really need to do that, right? So if I have a well, the idea would be, this is how Susskind explains it, right? So this is one of the guys teaching the most advanced relativity, Einstein's theory, and his explanation is waterfall, right? And then the well, and the water going down the well goes back up and comes down the waterfall. Yeah. So his way of accounting for it is not that it has to go to another universe. It just goes to the outside of the universe and becomes part of the water, part of the fluid system. The new water injected into the universe comes from the holes and comes back out the outside. So it's all very circular, and it conserves the water, right? Conservation of water. But there's no mechanism. There's no physical explanation for how it goes back up the waterfall.
More problems than the theory solves. Okay, at this point, I can anticipate the electric universe not just whining about the many worlds.
Everybody should be whining. Everybody should be saying, well, how come it's okay for you to do this in one case, but you can't do it in the other case? And isn't this just hypocrisy and duplicity for you to claim some other theories null and void because it uses a sweep under the rug bullshit, and then you sweep shit under the rug and do the same damn thing? I mean, it is hypocrisy.
Interpretation of quantum mechanics and call hypocrisy as it uses multiple universes to explain stuff as well. Now, my response is simple. The many worlds interpretation is just speculation. It's not.
Oh, whatever. It's just speculation. Our theories are just speculation when we want them to be. Are they a real theory the next day? So again, it just doesn't mean anything, right? Speculation, theory, prediction, composed model. I mean, what are word games to be playing? These things are proposed as realistic options for the truth. And the point is that those options have this elemental defect, which is it's got a big pile of woo smeared on it. First, the very existence of other dimensions, and then some notion that one dimension can push its problems, its mathematical problems, into the other dimension. First, you have to say there's some reason to believe there's other dimensions. Then you have to account for, well, how does it make stuff go into that dimension?
Theory. Now, Ivan Yakovsky proposed that the ether might be converted into new matter rather than being absorbed or destroyed. But again, that still creates more problems than it solves, because this suggests that all objects will increase in mass over time. The idea of ether...
Yes, growing Earth and all kinds of other nutters believe this shit. So yeah. So there's a bunch of nutty theories. You really haven't done science. And because I think if you just apply the logic, you can figure out that, yeah, the best answer is the universe is in chaos. There's a bunch of pressure inside the universe of this stuff called energy. And it's all in this invisible form. 99.9999% of it isn't pushing a piece of matter right now. And it's free in the universe creating, okay, what will be a pushing event. And everything is getting its atoms pushed into its core constantly. And all that movement creates a lot of heat. And that's why the core of the Earth is melted.
Ether streams was then also never accepted as a viable theory. Going back in time to 1671, Robert Hooke proposed that all bodies actually pulsate in the ether and that this causes ether waves. He argued that massive objects move towards the source of the wave. Now, about 200 years later, James Chalice picked this idea up, and he actually formulated a mathematical framework for this, which appeared to work, but it brought a...
It's exactly the opposite, obviously. I mean, the pulsating would create pressure going away, not towards. I mean, there's lots of problems with that kind of a theory.
Interesting prediction. If the wavelength of the wave created by one object is large compared to the size of the other object, then there would be an attractive force. If the second object is larger than the wavelength, the bodies repel. And Chalice claimed that this could actually explain all forces. The question then becomes how large the wavelength...
That's almost a... what's his name? Franklin Who theory. Yeah. This idea of waves being compatible, they hit each other on their peaks or they hit each other on their troughs and all this other mush. But you really don't need to go there, in terms of you're not going to be able to create any kind of consistency with that theory, because every time you change the distance, you change what's destructive and constructive. And clearly electrons don't do that. They always repel. You can't make them attract because you put them at a certain distance from each other.
Lengths need to be. Now, two galaxies will be attracted to each other, so you could say that the wavelength needs to be larger than a galaxy, but then the wavelength is larger than pretty much anything, and it's always attractive. But then you could say that this is extreme, and you only need to consider the constituent parts, and then you can take that down to a subatomic level.
Okay, so he's just making these little arguments against it. I don't like it for a lot of reasons. He don't like it for some reasons. But whatever. It's a not likable theory.
And this is where it gets interesting again. Take a positron and an electron.
So why would we bother doing that? Take the figment of our imagination and the real thing called an electron. I mean, it's just, again, what is a positron? Where are they? How would they fit inside of an atom? What is the point of talking about this stupid particle that doesn't exist? If it existed, we could do experiments with positrons all the time, because it'd be positrons. They'd be exactly the same as an electron, except they positively charged. It'd be so cool. There are no such things.
They would be attracted towards each other. Both are infinitely small particles, so you can't have a wavelength shorter than the width of an electron or a positron. So far, this holds. But then you swap the positron with an electron and they repel, which is odd considering that this requires a wavelength shorter than the width of a particle, which is infinitely small.
So again, infinitely small particles is what they're talking about now. So again, why would you speculate that they're infinitely small? I mean, why? Why would I say something like that? They obviously have a charge density, and so, it just... If they're infinitely small, they can't ever see each other, technically. How could they ever see each other? How could they ever, if they're so tiny, how could they ever send a ray that would hit the other one? Or, they could never see each other if they're infinitely small. You could never hit one. So it doesn't make any sense. Atoms and electrons and protons obviously can see each other. They can't be infinitely small, or they couldn't see each other.
Which leads to the question, how can you have a wavelength shorter than 0? Of course, you can get around this by considering the electron's wave function, but then there still is the...
So I don't know why he went on this tangent. He should have just gone to the next stage, which would have been to mention Lesage gravity as one of the things Newton was, like I said, Fadio submitted his argument to Newton. Newton signed it, which means that, in those days, if you put your name on somebody else's paper, it was a way of saying, I've read it and I agree, it's viable stuff. And so, but then later, a few years later, apparently, Newton lost some interest in Fadio's physics. But the fact is, Fadio is the one who started the fight between Leibniz and Newton over who invented calculus. So that's the irony there. So Fadio was still a very big supporter of Newton in that argument. So, yes, whatever. Drama. There was drama in the past, drama in the present. Shit. I think people would grow out of that crap by now. Alright, back. Do a little bit more.
Issue as to why the wavelength of the first electron's ether field would change depending on whether the other particle is an electron or a positron. Chalice was not privy to the knowledge of electrons and positrons, but the objections at the time were actually already simple enough and far simpler than those issues I've described. If matter creates these waves, then matter must always be imparting energy into the ether. Where does this energy come from? James Clerk Maxwell pointed this out, and in fairness, James Chalice was very quick to admit that he hadn't really thought this one through.
Right. So this is always sort of an issue, is you've got to account for, if you're going to, if there's going to be a mechanical, physical thing that creates a differential, you have to explain how the differential is created. So again, the Earth is creating this differential, I would argue. So where's the energy go, or how does it not build up, or some other, there always has to be an explanation. And the point is that the force is moving the speed of light. When it's pushing matter, it's moving it a lot slower than the speed of light. So therefore, the force has lost energy just moving matter. Just a fact. Moving the matter is degrading the energy of the force while it's moving the matter. And that's probably simple enough. But anyway, but you do have to account for that.
Now, there are many more ideas that people have entertained throughout history, but it is time to move on to the king of the mechanical explanations for gravity, Lesage's theory of gravitation.
So again, it wasn't Lesage's theory, which is sort of irritating. He bought rights to the papers of Fadio, and he basically just resold Fadio's theory.
Is also known as screening, and it was first developed by Nicolas Fassier de Douillet.
There you go. So at least he got the credit.
In 1690, and developed further by Georges-Louis Lesage in 1748. Even though this is the...
So this is way after Newton, So Fadio was contemporary to Newton.
King of mechanical gravity concepts, this was never fully accepted as a viable theory. At first, this was due to the explanations not really...
So it was accepted as a viable theory, so that's just not true. But like all theories that are mechanical, you could break it. So unless you mechanically structure it very carefully, it's going to be destroyed by this obligation to explain where the energy comes from.
Offering anything testable, but other problems popped up over time. The idea behind screening is that all of space is filled with particles, or ultra-mundane corpuscles, which have some momentum, and these particles travel in random directions like particles in a gas, and when these particles hit proper matter, some are absorbed or deflected, depending on what...
So again, he uses the word absorbed and deflected as if that isn't an elemental concept. That absorb is taking the momentum, being moved by the momentum, and deflected is, no, you reject the momentum.
Version you're reading about. In any case, this corresponds to some momentum being transferred to the proper mass. So we take object A, which is being bombarded with particles from all direction, but then...
So I understand that that's exactly what it would look like, right? That's exactly Einstein, that's exactly all this other stuff, right? The ether theories, the rest of them. same end product if you just count the ones that hit you. So he's describing a theory where they're moving in all direction, but he's illustrating it pretty clearly. We're only going to talk about the ones that are heading right for you. And it does make a huge difference. And obviously they have to have a size or they wouldn't be able to collect anything.
We introduce object B. Object B blocks some of the particles coming in from the direction of where object B is, and this means that one side of object A isn't being bombarded.
So this is a real mechanical thing. So you could really do this, actually. You could actually put a gas into a thing, and you could put two objects in there, and the gas molecules will bounce all around, and they will push the two things into each other. So you could make it with, like, say, mechanical BBs. If you give them a very reflective container to exist in, you could put that energy in. You could put two objects in, and they'll move. You can do it on an air table or some other kind of way. But I'm just saying you can mechanically duplicate this function where the A will be attracted by the B and simulate gravity
with these particles. So the pressure isn't uniform over the surface of A, and there is a net force acting in the direction of object B. You can take the reverse being the case for object B, and object B is accelerated towards object A. So here we have mass appearing to attract mass. But we have to consider the inverse square law as well. The body...
So it is, it's not two-dimensional, it's three-dimensional. So the inverse square law is simply recognizing that it's coming in all directions, and the shadow is going to be cast as a cone. And the cone gets bigger and bigger and bigger the further away you go.
That is blocking the particles from a certain direction will subtend some solid angle, and particles coming in from this angle will be blocked by the object. The solid angle that the object subtends is given by the object's cross-sectional surface area A divided by the distance squared. So this satisfies the inverse square law. Where does...
Yay! So, which is huge, right? I mean, it's kind of that's a big one to overcome, is having to create a mechanism that does this 4 times as weak at twice the distance.
What goes wrong is when you consider the conservation of energy. If you think of the body being in an equilibrium state and the body is bombarded with these particles from all directions, and we take the mechanism to be that the bodies absorb these particles.
So we know that he didn't spend any time really thinking about this. He just read the argument and the debunk, and he's just going to recite the debunk. But he's not going to really think about it and say, well, maybe there's a way you get around that. So it's not that hard to think of ways you get around that.
And the body would heat up as their energy is absorbed.
Exactly what the Earth does. It's got a molten core, sort of a giveaway.
We take the mechanism to be that the particles bounce off the body and transfer some momentum, then we run into trouble. If all collisions are perfectly elastic, then you can imagine that there exists a particle C which would have struck object A.
Right, so again, perfectly elastic or perfectly absorbed would be the argument. So there's only 2 choices. It bounces off without giving it any energy, like a brick wall doesn't absorb any energy. Newsflash, you can say it does, but it doesn't. Or it absorbs the energy, keeps it. Those are the 2 real choices. I mean, there's a real physical explanation that says, yes, I hit something. If it bounces, nothing happens here because all the energy is now going that way. It's gone in a new vector. You can't have 2 pieces of energy. It can't turn into 2 pieces of energy. It either sticks or it bounces. Those are the only 2 choices. It can't stay discrete and free energy. To evade free energy, you really can't give the B momentum and create a reflection. You can't do both of those things.
But it's blocked by object B. But it is equally likely that there's a particle D which would not have struck object A and now would strike object B and be deflected to strike object A. As a result, nothing would happen, so we have to conclude that the collisions between the particles in proper matter are inelastic, and this means that...
So that is just fake. So that's not a flaw in the theory. It will factually block more energy than can sneak in at some angle. So it just doesn't mean anything.
some energy must be lost in the form of heat, and considering the magnitude of the forces we are dealing with, a lot of heat. Lesage's theory is interesting. When you go from the start, it seems pretty sensible and it appears to work. It describes how massive...
Right, Feynman used it as an illustration of a very good theory. It fits everything, and then he says at the end, but it doesn't. Problem is, it doesn't work. And the problem was just the drag argument, that if you did have a field of actual physical particles that were moving things, well then when you moved into that field, you would have to interact with more of it, would be hitting you from the face than behind, and therefore you would lose your energy. And it's not an unreasonable statement, frankly. That one's a tough one to overcome, as just it's on its face says yes. The trick is, I pointed out 2 years ago to him, well, what if there is drag? I mean, there's every evidence that electrons and protons are, in fact, dragged to a halt. That I can shoot them through a vacuum and they will not keep going. Just a fact. They won't.
Appears to attract mass, and it can even describe how the force is...
And this is even in the comments section of this video, where I point that out, and they talk about accelerators. There's no evidence that accelerators have the biggest electrical bills going. I mean, it's an insane amount of energy they have to use, but they have to keep pushing the particle. Accelerators can't just shoot, okay, a particle, an electron, and have it go around and around and around and around and just come back 3 days later and it's still going around and around. They don't have to just energize it with magnets, keep it on its path. They have to keep pushing it. Just a fact. If they stop pushing it, it stops moving.
Proportional to mass. As the cherry on top, it also obeys the inverse square law. But you also have to evaluate the ideas in the context of the time, and there wasn't really any notion of thermodynamics, and there wasn't really much of a formal definition of energy.
Well, you don't need any formal definition to understand the idea of conservation, so they all kind of tended to think very positively of the idea of conservation of energy. So in a sense, Descartes sort of made a persuasive argument in that direction, that the universe has a certain amount of energy in it, and you can't make more and you can't destroy it. And that's what everybody does believe. So, there's nothing inherent in the theory that has anything to do with those conservation laws.
And it all seemed to work, but even at the time, the idea of screening was still treated as highly speculative by virtue of it not really being testable. As our understanding of physics developed...
Okay, so this testability, screening, he's calling it, this has nothing to do with Michelson-Morley. That's clearly an ether issue, and that's all... Michelson-Morley they wanted to prove the existence of ether. They weren't talking about Lesage gravity. So the two are not the same thing. It's not the same conversation. Alright, so I guess I'll stop here. We got at least a taste of Fadio gravity. And we'll see if I feel like making a second video. So I'm not gonna publish this on YouTube at the moment. Maybe, it'll never be published, who knows. I'll just make it a unlisted video for now. And because I've made these arguments over and over and over, and there really isn't any response, and you can't force anybody to make responses. You can't obligate these liars and cheaters and frauds to actually defend their nonsense physics, and that's a real problem. Because it's really just a waste of time to make all these counter arguments to 100 people. Just a waste of time. So anyway, till the next time and such.